this is where we had already left off. And I did also fix it so I can now see what I'm talking about inside the document, you know, just in case. And that, I don't know why that came up. That's not good, but that's okay, that bar. We were talking about tracing and going to each top of each bin. And when I say top of each bin, it's kind of like I'm on top of this piece or on top of this piece. And it tells you how many there are. If I just look over here, it tells me everything I want to know about each of those intervals. The last paragraph was that if you decided to use 3 bins instead, and there's a mathematical way to get what the interval would have to be by hand. In other words, if you know you want only 3 bins, you could take the max minus the min, divide it by 3, round that up to a number, and then you can start with your smallest and do that window and so forth. And so if we need to do that by hand later, we'll try that. Maybe for our, we don't have a whole lot of data for pulse rate, so we'll do it by hand first. In a minute, we're going to need to do that. Okay, so any questions that we had that day? We're good? So if we move on, we're now being recorded. So the last time we met, we created the histogram on the NFL data. We also collected our pulse rate, your sets over there. We probably will be using it today. All right. And did everybody, even if you did have your calculator in class the other day, you were still supposed to get that histogram in your calculator? Probably still is there. So I'm going to start off, again, we're still in descriptive statistics. And got to get on the right page here. Next page. He says, since we'll be using this data several times, the NFL data, it does come up in a couple other problems. We don't want to, it took us a while to key it in. So you don't want to have to key it in every time. So he tells you a secret if you want to put it somewhere else. So what we're going to do is, up in here, we're going to, does it just record when I move? Yeah, it's probably better when it just moves. I don't know why it makes that line. Since we'll be using the same data, the directions here, oh, okay, something else happened here that prevent me from, okay, that's off, all right. Trying to move my page and it's not letting me. It's not what you want to record. Oh, I know why. It helps to press the right button. We're going to go back into your data, you still have, with stat and edit. And what we're going to do is we're going to move our cursor to the very top of the list of data. And you'll notice it says L1. But what we're going to do is we're going to go over to L3, and it's blank. In L3, we will press the Enter key, and it's going to ask us to, what do you want to put in L3? And we're going to tell it to put L1 in L3 to save later. Now, here's the bad part about the video. I put this iPad down, and in order to do the video, I've got to bring up the computer on top of this. So this is what's being recorded. So the person's going to be staring at this while we're on our calculator. So let me bring up you get your calculator out. And I'm going to get my calculator out. Okay. Actually, I'll unzoom it for now. So there's the calculator that is not going to be shown by the video. So they're just going to hear us. So my data is there. And if you hit Stat, Edit, stat, I'll do it from scratch. Stat, number 1 is edit, and that's what you already put in. And I can move over to any column of data that I want. And notice when I go up, it actually tells me all the data that's in L1. So he wants us to copy this into L3 because, you know, personally, if I want to use it in the future, I don't want to lose it. I probably even go farther over in the L's because the odds of you needing 7 lists of data at one time is rare. But 2 or 3, it happens a lot. But right now, I'm going to follow his directions. I want to paste all of L1 into L3 to store it because we're going to erase L1 and we're going to be putting in our data for our heart rate. So to paste that, the directions said, at the top, press the Enter key. And at the bottom, he's asking you, well, what do you want L3 to be? And it's what's nice is you can tell it to be, you can multiply by list 1, you can take list 1 and take away 3, and that takes away 3 from every term, and then it pastes all those numbers. It's really, really nice. You can do a lot of things with this L1 and put it in somewhere else. But I'm just going to say, I want to paste L1. Now, here above the 1, you'll see in blue is the L1. So it's second, number 1, it pastes the L1 here. L3 will be equal to L1. And when I hit Enter, L3 now is pasted for later. Now I want to save it, I don't want to erase it, or I want to use it later. Maybe I push it farther over, just depends. Now I want to clear L1 because I'm going to use it. So I go back to the top of L1. Be careful. There's 2 things you could do. You could hit clear, or you could hit delete. Do not hit delete. If you hit delete, it does go away. But so does L1. The whole column goes away. And you'll keep saying, how do I get L1? Where did it go? There is a way to bring it back, but it's really a pain. So hit clear and hit Enter. And L1 title is still there, but everything is gone. All right? So let's see if this could come back up. Okay, I brought it back up. Oh, wow, you know what? I didn't realize if I played my cards right, I could use the calculator while this was still up. Look at that. But then it's kind of small, but you have it on your paper. So if there's any issues, do let me know. And this I don't really like. So I can't do it from there. Maybe it's this. Nope, that didn't help. That didn't help. Made it worse. I don't know. I'm not really sure why that came up. And there's no close. Anybody see anything else? Say it again. You see the word close? The blank side? Yeah. Like over here? Yeah. Yeah. Yeah, it doesn't seem to do it. I don't know. Interesting. Anyway, oh wait, maybe I go here. Oh wait, now it went off. Okay, I pressed the hand. All right. So this first line was storing L1 into L3 for later use. And now example 2. We just did example 1 was the NFL data. The collecting the pulse data was just an activity to collect data. Now go back to the first page and enter the data for your pulses you collected. So let's practice with the calculator first. We are going to enter the data from our pulse rate, our class, into L1. And we're going to, you know how fast it was to do the histogram with a calculator, was really, really fast. So we can actually all do it together. I'm already in L1. I think I can work with this. If somebody wants to read out the values, it's faster for all of us to get it in our calculator if somebody tells us what to type. So who's my volunteer? All right, Mr. Mohammed, real loud.
69.
69, and, oh, yeah, hit enter.
61.
61,
86.
86,
58.
58,
70.
70,
94.
94,
86.
86,
65.
65,
83.
83,
Yes, sir. 68.
68,
79.
what was that again?
79.
79,
71.
71,
88.
88,
97.
97,
And last but not least, 75.
last but not least what?
75.
75, and that tells me that's our 15th, oh, then that means we had 15 people because somebody was not sitting here or something? Oh,
This month.
okay,
You left.
he left, Christian,
Yes.
and,
Mallory.
but Mallory was here.
No,
No,
Mallory
Mallory
is
was
here,
absent.
but not today.
But Mallory was here that day,
Yeah.
okay, so that's fine. All right, so I hit enter on that. Review with me, what do we do to see this histogram without having to do any thinking? Does everybody remember the steps?
Oh, just that on.
It was stat plot, that's right, stat plot. Second, y equals, turn it on by hitting enter, making sure it's on. Of course it's on because it was still on from the other data. And make sure histogram is highlighted. That's the third icon over from the word type. Make sure I'm looking at list 1. Right now I could put list 3 here. I have data in list 3. You'll get the same picture as we did the other day. And so it looks good. So what do I do from here? I'm ready to see it.
Graph.
Okay, graph. Did it, oh wait, that's weird, graph. What did I not do? I've got to tell it to zoom the way I want to see it. So zoom stat says, calculator, Mr. TI, I call him Mr. T. Please give me the best graphic you think you can do with this data. So I do zoom. Zoom is which number at the top of your row? Third one. Zoom number 9. And okay, look at that. Your data is also skewed to the right, which implies we have, we're dying. Not really, because, well, if skewed to the right actually meant the right tail is at the higher values. And it's a tail, it's smaller. So there's not that many people that's in the right side. Most of you are in this bulk, and that's okay. So that, and let's see, if this was a homework assignment, you would have to label your title, you'd have to label the axis. This axis again would be frequency. This axis would be pulse rate. That's right. So we need to put this on the paper. You have a grid there. So I'll help you do that in a second. But before I do that, hit the word trace, which is your 4th top button. So I can at least realize, oh, okay, they divided into 1, 2, 3, 4, 5, 6 bins. That was his choice. He could have done 7, but then it would have spread it out. He could have done 4, but then it would have compressed it. So the calculator, Mr. T, knows best, says that the 6 was an optimal look. And so the first bin, we've got 3. You might want to write that down or make that note somewhere, because we're going to put this on our paper. And the interval went from 58, and the next interval starts at 65.8. I need someone to do the math. What is 65.8 minus 58? Are you stuck on something?
Yeah.
Did you hit zoom number 9?
Yes.
Yeah, yours is different, are you sure, do you use the same data?
Use it quickly.
Did you plug in the data wrong? Just check the data, let's go stat, edit. Did anybody else get this picture?
Yes, sir, I did.
Okay, yeah, double check the data that, well, we're getting the data from up there. That, the data came from our class. It was these numbers here. Oh, no, yeah, 3A stats. It was 69, 61. Is that the data you're using? Okay, try it out. So anyway,
7.8, sir.
say it again.
7.8.
Thank you. So 7.8 is every interval. So you might want to take notes here really fast to realize that the first one had 3, and it started at, the min was 58. He added how much, did you say, sir?
7.8.
7.8, and got to the next bin of, well, you don't know yet until we hit, well, we know it goes to 65.8. That's where the next bin's going to start, because the right side of the bin counts for this bin, not the bin on the left. So in order to get the next bin, just for kicks, what is 65.8 plus 7.8? Say it again. 65.8 plus 7.8, I think it's going to be 73.6. Is that right? So the next one's at 73.6. And the easy way is just to hit the plus, the arrow to go over and see. Oh, yeah, there it is, 73.6. The second bin has 4. So the second bin has 4. And the next bin, I'm going to hit the button, 81.4, and there's 2 of them. So it goes to 81.4, and there's 2. And then the next bin, I'm just going to go to the next2. This is for my scratch paper. Next row, 89.2, and there's 4. So 89.2, and there's 4. And the next one is, hit the right arrow button, 97, and there's only 1. And there's only 1 up there. And I know I'm adding 7.8, so I have a feeling it's going to be pretty easy. It'll be 104.8, so I'm going to show you. Arrow over, 104.8, and there's 1. 104.8, and there's 1. So if I'm happy with this histogram, let me go back to my paper. There it is. Back to my paper. Get my pen out of here. And we're going to try to draw this here. So I am going to try to draw it in this grid here. My scale, my vertical, that is keeping track of my frequency, goes from, let's see, the max. The max is 4. I have a 4, and I have 1s. So that's going to be really easy. 1, 2, 3, 4. There's 4, there's 1. The bin width starts at 58, so I will start here at 58. And how many bins do I have? 7, was it? So I'm going to take off, that's 1, 2, 3, 4, 5, 6, and 7. And I've already labeled all the numbers. So it's 65.8. Whoop, messed up. 65.8. What's the next one? 73.6. 81.4. Should have made it bigger. 89.2. 97. course, yours will look better than mine. And 104.8. Sounds like a radio station. All right, so my first frequency, according to the calculator, was 3. So I take the right side of this bin and I go up to 3. Whoop, make it straight. Go over 3. Didn't even put 3. Next one was 4. So I have to go up 4, go over 4. Next one was, I don't remember. How many was at 73.6? I don't think I marked it. Somebody take your calculator and do the left arrow key to get to the third bin. There was 2. So 2 would be here. And then at 81.4, there was 2 also. Are you sure? I don't think the third one was 3, 4, 2, and then 4 again. Oh, that's what happened. I put the 2 there. So that one's 4. So I'll go 4 for this next one. Then there was 1 and a 1. Is that right? Wait, I'm missing a bin still. Yes. Where at? Oh, here? Okay, so let me, I thought I was writing what I heard, so let me get rid of all of them. This is why I pay you guys the big bucks. And that way it'll make it easier for me to write it in. Okay, yeah, that's what's important. So give me the numbers again. It was 58 and then
65.8.
65.8. And then
73.6.
73.6 then.
81.4.
Good. And?
89.2.
And?
97. 104.8.
Oh, that was the last one? Oh, okay. And then I do want the right end point after that, because that gives me 1, 2, 3, 4, 5, 6, 7. What would this final number right here at the end be right here? You'd still add the 7.8. What's 104.8 plus 7.8? $104.8 plus 7.8, just to get the borderline here. Louder, please. 112.6. Okay. Are these bins? Are these bars okay? 3, 4, 2, 4. Are they wrong too?
No, they're right.
Okay. So what's the next bin then? How many was in starting at the 89? Was it 89.2? How many is in there? Only 1? Really?
Yes.
1, 2, 3, 4. Why do I only see, was I wrong on the 7 bins? Was there only 6 bins?
Yes.
Oh, I was wrong the whole time. I said that earlier, right? Don't be afraid to say I counted wrong. So I won't need this last one. Okay, 1. Whoop, I don't want that color. 1, and I don't need this at all. Okay. I want that erased. It's odd. Questions? So that was with the calculator. We need a title, as always. Gotta have our title. What'd be my title? I'm gonna go period 3A stats heart rate. Heart rates. It is the distribution of this sample. Questions? That's with the calculator. You still had to go back and had to do your tracing if you choose to use just the default what the calculator came up. But what I want to do now, I don't know if I can add a blank paper on this. I would really like to have a blank paper into this. Let me try it. Add a blank paper and see what we left off on here. Well, okay, I hinted to this stuff already. Shapes of distribution. A distribution is symmetric. See that right here? Symmetric if the right and left sides of the histogram are approximately mirror images. So if you look at the bottom here, without looking at the words, which 1, 2, 3, 4, 5 look more symmetrical? They actually gave it to you. You can cheat. But which one looks like a rectangle? Third one, right? So if I was a betting man, you know, I would pick that because it looks so much like a rectangle. And we've talked about the term skewed. The distribution is skewed right. Can somebody else finish that reading, please?
If the right side of the histogram extends further out than the left side.
Which of those pictures, without cheating, which is farther right? Exactly. You see this tail? Skewed to the right. Which one skewed left? The last one, yeah. The last one, you see that tail? Now, would you think that maybe the first one also looks like it could be skewed?
Yeah.
Yeah, but is that tail farther out than this tail? It's not really that farther out. This may be narrower, and that's exactly why they still call it symmetric. It's still symmetric. It's because it has, the tails are about the same on each side. Even a perfect normal curve. A perfect normal curve is symmetrical because it's got a mirror image. If you cut it down in half, you could fold it over. And this is the same picture as that picture. So this could be cut in half here, and it's almost the same. It's not perfectly symmetrical, but it's close enough for government work. It'll pass. How about this? If I cut this down, does it look symmetrical? Could you fold it over like a sandwich? Yeah, you could. But they also told you something here. What's this word here? Bimodal means two humps. This is actually, if I trace around it, I would call this more unimodal. Bimodal because there's two different peaks. This really merges into one peak if you really want to talk about it. This was symmetric, also uniform. I should really correct myself. Symmetric doesn't mean the rectangle. The uniform means rectangle. Symmetric just means it's the same mirror image if you cut it in half, that's what happens here. And this is skewed to the right, this is skewed to the left. Questions on that? That's just terminology. Stemplot. So, Stemplot, this is new for you. That didn't help because that's not the eraser. This is the eraser. A Stemplot, let me do the shading this time. Sometimes called stem and leaf. So we're going to make stem and leaf. And so your job is going to be, we got data here, and stem and leaf is good when there's boys and girls or cats and dogs or people from 1920 and people from 1921, and you want to compare the shape of both pieces of data. And this stem plot is already done for you. Take a look at it here. Thank goodness you're not having to do it. But if you look very closely, this data here, all the girls, this number here, these two numbers go together as we'll call that the girl data. That's a 93. I'm sorry, I lied. Let me do it again. That data is it goes left to right, 39. For a boy, there's also a 39 for a boy. And if you look up at the data, let's see, I think I could find them. They're there somewhere. 39, 39, somebody tell me where they are. Oh, here it is. Here's the boy data, 39 girl data. It's like looking for a needle in a haystack.
On the bottom,
Bottom, in the middle,
67.
39. So there's that one. That's how you read the data from a stem plot. This is called your stem right here. That's your stem. And the reason they call this stem and leaf, you could pretend it looks like here's the stem and here's your leaf coming out. The veins of the leaf, you see the veins of the leaf? Are these things here? Stem and leaf. Or we get lazy and say stem plot. Same thing. It just depends how fancy you want to be. And nobody's ever accused me of being too fancy. So I can list all the data if I truly wanted to, and I really don't, but I'll just list a couple. Look at here. I'm going to do the boys. That's a 42 and a 47 and a 48. The fives, 52, 50, what else? 53 and a 59. 62, 63, 65, 66, 67, 68. So if we didn't already have the picture and you were supposed to create the picture, you'd have to sort the data in order because you have to have them in order to know where they would go. And then you got to decide on how am I going to count my stems. Well, I'm going to count my tens place to be the stem, the tens place. So I do a 3, 4, 5, and you find out your min was a 39. I find out my max is a 98. See that 98 on the boys' side? So I would go from 3 to 9, and then I would fill in order as best as I can in order. Okay? And the girls the same way. I've got the 39. I got a 40. He didn't put it in order here. 44, 42, 48. See that data? 54, 57, 58. That one's okay. 54, 57, 58. It's not that it's wrong. It doesn't change anything about the picture. So to create it, you put your data in order. And you don't have to have girls. You could have done a stem and leaf on just one set of data. Which I bet you any money we're going to do a stem and leaf on your data. Okay? It could happen. By the way, the stem doesn't have to be single digit. If you know you got a lot of values that go up into hundreds, it could be a 1 0 for 110. 1 1, I mean 1 0 would go hundreds. 1 1 would stand for 110 if you go 0, 1, 2. You have that level. Okay. But this problem he had boys and girls. So you put them together because what we really like to do is compare the two sets of data. I have a feeling we're going to compare boys and girls with a stem plot. I just have a feeling. And if you look at the stem and leaf shape, I'm going to go a shape over here. And then I'm going to do the girls as well. And do they look much different? By the way, what was these for? These were, what was the results? What were we graphing here? It says, final exam to several classes and examine the grades by gender. So if I was really a betting man, I wouldn't see a whole lot different between the boys and the girls on this test. Except for More boys scored in the 90s than in the girls. But I'd have to count each of these up to see, well, let's look between 80 and 90, or let's go from just the 70s and above. Which class had more pass? So you could do that. What else could you do? You could look at the data. You know what? Shading doesn't erase. That is really odd. I didn't know that. I thought everything could erase. Live and learn? What does this do? Oh, I bet you this paints. Let me do this. No, it's not doing anything. Just look pretty, that's all. Back to erasing. Oh, there. Got it. How would I find the median of the boys' grade? How would I find the median of the boys' grades? Somebody real quick. Do I know how many there were? Did he tell us in the reading? Can you count them? Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 2 of those, that's 34. 34, so what's the median of 34? Well, 17 is half, right? 17 and 17. So I have to really use the 17th and the 18th value. So I start at the lowest. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Here's the 18th. There it is. It's between what two scores?
72, 73.
Oh, you're so good. You didn't just say 2 and 3. Yeah, 72. What happened here? 72 and 73 is between it. So what's between those two? 72.5. You could say the median, big M, 72.5. So that's a good judge of center, median. Let's look at the girls. How many were there? I'll count from here now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. Okay, so 15 on one side, 15 on the other, and 1 in the middle gives you 31. That's the 16th number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. The winner is 75. So the median is higher. So you could probably say what? Who did better, boys or girls? Of course, as always, right? So that's a median. That's a median, big M, median. I could do the max. Who had the max? We already said that the guys did. The men, who had it? They tied the men. Both had 39. So there's a lot of things you can talk about by looking at this picture of a histogram. Do you see where I'm coming from? So let me go to the next page. Yeah. So what I want to do is I want to do it completely by hand now. Okay? So assuming, not that the calc test, the AP exam, nothing's ever all by hand. But, you know, we're better than that. So I'm going to still make my axis. But here's my mathematics. My max was, what was my maximum heart rate up there? How much?
94?
94?
No, 97, 97.
97. Okay, let me fix that. It's okay. If I can count to 7 and there's only 6, you can say that. What was our min? Who was our runner?
58.
58. So if I decide, I'm just thinking to myself, if I'm doing this for myself, I'm going to do the range, which was 97 minus 58, and that is how much? Don't all do it at once. How much? 39. And I'm going to ask myself, how many bins could I get out of 39? If I divide by 2, it's not enough. 4, that'd be almost 10 with each, but maybe 4 is not enough. So I could say 5. Let me do 5. Let me be different than the calculator. What if I say 5? And I pretend instead of 39, I'm looking at 40, because I can do the math in my head. 80 divided by 5 is... I'm sorry. 40 divided by 5 is? 8. So if I choose to do 40 divided by 5, that gives me 8. That would tell me that the widths are 8. So I will start you said my min was 58. I will put 58 there. 58. I don't have a problem. Oh, I don't want that to rotate, but it's going to rotate. 58. And add 8 to that. Somebody? 58 plus 8, 64. Don't make me do all the work. 64 plus 8 is? 72. 72 plus 8 is? 80. 80 plus 8 is?
88.
Tell me when to stop. 88 plus 8 is?
96.
96. What was my highest?
97.
Oh, my highest is 97? I thought I was doing 5 bins. 1, 2. What happened? Tell me what we're saying or thinking.
58 plus 8 is 66.
We're at.
Oh, that's true.
We're at.
The
64
first,
instead of
the first
64.
number
It was how much?
66, not 64.
Oh. And I did that. See, I told you don't make me do all the work. You make me do all the work, then obviously there could be an error there. How are you doing?
It's the only time I could get away.
No problem. I couldn't get away. It's one of the things.
I know, you're busy.
Ah, it's okay. I got it. Thank you very much. I appreciate it.
It's in the lounge.
Honestly, I don't know what.
All right. Yeah, if you rely on me to do all the math, you're going to have a lot of errors. So somebody should have yelled at me a long time ago. So 60 what? 6. Go on here. 66, 74, 82, 90, 98. Is that all I need? Yeah, because the highest was what? Yeah, so I knew 5 should have gotten it. So I knew I made a mistake somewhere in the mathematics. And I'm the one that did that because I was waiting for you guys and you didn't answer me. And I said, oops, okay. So now I'll go back to my data up there. And I didn't sort it or not. But that's your job right now. Go, looking at our data, how many are between 58 and 64? How many? I heard somebody say 1.
No, it's 2.
It's 2? Okay. So I'll go.
58, 64, 61.
All right. So you say 2. Final answer, 2?
It's 66 on the board, so the 65 counts.
Oh, right.
There's a 55 up there?
There's 65 up there, but it should be
61 and 64.
Okay, so 2. So I'm going to go up to 2. How many are between 66 and 74?
You know, Mr. Cartwright, actually for the first one, it's 3 because there's 65.
Oh, there's a 65. I thought somebody counted that.
Yeah, I didn't see that. But Miranda pointed it out.
Okay, good job, Miranda. So we will go up to 3 then. 3. Well, it's 3. Then the next bin. 4?
Why me?
So final answer? 4. So 1, 2,
Okay.
1, 2, 3, 4.
Yeah, I see 4.
Next bin.
Two. Two.
2. Final answer?
Yes, sir.
Next one.
Okay, so that's 1, 2, 3.
I thought I was bad. Final answer by the majority? 4 again. So I go up to 4 again. Okay, we got one more bin. And, you know, by default, we had 15 up there. So it's 8, 9, 10, 11, 12, 13. There should only be 2. So double check.
Oh, I counted 97, but this one.
2.
2. Okay, so there it is by hand. Now, if you compare our picture with the original, it really doesn't look much different except for the computer had 2 of them at 1. But because I only had an interval of 8 and it had an interval of 7.8, it kind of fudged the boundary somewhere and we stole one from somewhere, messed it up. Actually, 2 bins changed. But the idea is still there. I actually kind of like this picture even a little better because in talking about what I mentioned before is if you were to do a curve about it, it doesn't look too skewed. Doesn't look too normal. It looks more, it looks closer to getting closer to symmetric. Symmetric would be like a rectangle. And it's almost a rectangular block. But you know, with only 15 data items, it's hard to really get a great picture of our data. But I at least can tell you, let's see, if there was 15, the mean would have been the 8th number. Watch me. 3 plus 4 is 7. The 8th is in the 2. The median is in here. So I know your median. I could say the median heart rate of this class is between 74 and 82. Because I counted it by labeling that. And the mean's probably not far from it. But I'd have to actually average those up to C. I don't really see a big tail. So the tail would have pulled the mean. The mean and the median should be about the same unless there's some weird behavior happening, especially on the outside. When you have weird behavior out in here, then what tends to happen is it pulls the mean. But enough of that. Okay, so let's see. I like this because I can actually put that little bit up in the way and say, quit bothering me now. And I can do another problem. That's kind of cool, I think. Nothing else I ever have. My smartboard won't let me do that. Let me go back to that page where we... Next page, that's my scrap paper. All right. 4. Following is the total number of medals in each country won in the 2004 Summer Olympics. Create a Stemplot for the data. So this is not a back-to-back Stemplot. The boys and girls was a back-to-back. This is just one Stemplot, and he kind of did you a favor. He put 0, 1, 2, 3, 4, 5, all the way to 10. Which means if I put a 1 here, that would be 101. If I put a 4 here, that would be a... If I put a 9 here, that would be a... If I put on the 6th row, if I put a 7 here, that would be a... 67. Okay, I can't fool you guys. So your job now, please get with a partner, because there's a lot of data here, and take your chart you're first going to have to probably put them in order. So it's going to be a pain, but we don't really care about the countries anymore. You're going to just put the numbers in order, and then you're going to build this up, okay? And I think what I'm going to do, I'm going to pause the recording because nobody wants to stare at this page for the next 10 minutes. So we'll pause. Just checking if I can add to this recording. Okay, I don't think, did anybody get it all done?
No.
Anybody close?
Yes, sir.
Oh, you did finish.
Yes. 5 more minutes.
Let me see a picture of it.
See from here, sir.
Okay, let me take a picture of it here. And maybe I can put it in our, it probably did stop. So let me add this picture. Picture.
Do you know how to use the calculator for like the graphs? Can you help me? Cause like I got so messed up. Like I got so messed up. Yeah.
Oh, it did. Okay, so I will done. Put it right here. Look at this. I'll put it right next to it. So let's all take a look at this because we only got like 4 minutes left. And I'll make it big first here. It looks like, that was nice. A lot of ones, a lot of twos, a lot of threes. Is this picture skewed left or skewed right? So you got to say, is the small tail going to the bigger numbers or the smaller numbers? The bigger numbers. Because look at here. A lot of doesn't do the, oh. You've got these up here. If you turn it around like this, look at that. Turn it like that, you'll see that it's skewed to the right. Okay? If I put the axis at the bottom here so that I can see it, it's skewed to the right. All right? And the median would be really hard to figure out. So we're going to stop here, but your assignment, yeah, is in that little packet that had 4 problems, I think. Number 1 and number 2. I'm going to ask you to make computerized histograms, the calculator. You're supposed to be able to choose what you want, a stem and leaf or a histogram, but you can't do a stem and leaf in the calculator. You can only do the histogram in the calculator. So I'm going to want to see you do those 2 problems.
1 and 2?
1 and 2. All right?
And then what about the...
So we're going to call it, so say goodbye in case anybody sees this, if I post this or not. Bye. I wanted to use the, all right, go ahead and re-enter the pulse rate for 3rd period into your calculator. This is my review and reteach of the previous lesson, just because. Y'all got it in?
What is the 7?
This one here?
Next to the D.
Oh, I don't know. I deleted it. It should still be on the board. Can someone tell me what it is? 7 what?
7-0.
7-0. Okay, we'll add that. Thank you for catching that. I don't know why I deleted it. Who knows why I do. All right. So, one of the things that our calculator did for us was when you did the stat calc, spelled it wrong, calc number 1 for one variable statistics, it gave you a whole bunch of things, one of those being X bar, the average, which is important to us. But I'm interested right now in our quartiles again. So if we go back and rerun that command on our data, whatever list you put it in. So rerun your stat calc number 1, and the numbers I need are my min, my Q1, my median, which is also considered Q2, Q3, and our max, which is also considered Q4, because it's the end. These Qs are the end of this 25%. So by hand, if I truly wanted to look at my data here, help me put these data in order, and you may have done that already for a histogram. So help me put these data in order. So let me grab it. Oh. So what was the smallest of that data? Don't all say at once. 58. Is that right?
Yes.
58. Then I see a 60.
51.
A 51 or 61? 61.
65.
65.
69.
69.
68.
Oh,
68.
okay, 68, then a 69, then
70.
a 70, yeah, 70, 71. I see a 75. Do you see the 75? 75. I don't think there's any more in the 70s.
79.
Oh, where's that at? Oh, there it is. 79. Any more in the 70s? Then I'm in the 80s now. 83 is the smallest. 83. Continue. 86. Another 86. 88. 94. 97. Okay, so if I'm doing these numbers by hand, now your calculator is not always going to pick the exact same one because there's human decisions being made. But there's 15 pieces of data. So what's 25% of that 15? What's 25% of 15? 1/4. If it was 16, the answer would be 4. But it's not 16, it's only 15. So the answer is a decimal, isn't it? What's 15 over 4?
3.75.
3.75? So if I'm counting 1, 2, 3.75. So it's got to be in here. It's going to be a fictitious number probably between that. So this roughly, I can't really go in there and get part of the 68. But I would say that 25% of the data, I'll pretend to go in there. Part of the 68, there's 25% of the data. And then if I want to go to the median, well, if there's 15, that was actually pretty easy. Because 15's odd. The trick was pretend it's 16. What's half of 16? No. 8. So the 8th term is the median, which is your Q2. 1, 2, 3, 4, 5, 6, 7. Here is your Q2 or your median. So what you could do, let me show you another trick. You know that Q3 has to be in the middle of the rest of the data because the data that I just did now in blue takes me up to another 25%. So I could just say 1, 2, 3, 4, 5, 6, 7 data. That's odd. Add 1 to it, make it 8. Fourth data. So let me start over here. 1, 2, 3, 4. So that would be the middle of that data. I wonder why it didn't work over here. I could try it again because I still have 1, 2, 3, 4, 5, 6, 7. So if I did that trick by hand, I'd pretend it was 8 and 4. 1, 2, 3, 4. So there is a good chance that your calculator calls it a 68. But regardless, it doesn't really matter if your calculator disagrees with you just a little bit. So if I'm making my quartiles, and I will try to keep it, let's see, it's not going that high from 58 to 97. So I can always make it 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70. You can't see it's too far down there? Okay, let me... There, how's that? It's on top of my numbers there, but that's okay. 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80. I don't know if I'll make it. I may have to shrink it. Which is the beauty of this. I can always, I can move it. That was 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90. I still need more room. So I'll just make more room. 91, 92, 93, 94, 95. How far am I going to go? To 90 what?
97.
97. So if I'm doing it by hand, I definitely would call 58 a what? What is 58 of this data? Say it again.
Minimum.
There it is. There's my minimum. 58. Then Q1, I'm torn between what I want to call 2-1. But if I take those 7 terms and make it 8, the fourth one, 1, 2, 3, 4, that would have been a 78. So I'm going to go, right? Is that what I said? Or 68? 68. So it's 5, 6, 7, 8. I'm going to call that a 68. And right here, I'm just going to put my dot and realize that's going to become a wall of a box, 68. In Q3, I'm calling it as an 86. So that was 85, 86 is here, so it's up here. And then what's this 97? Yeah, that 97 is way over here. It's a max. So I'm just going to put a dot because it's just a max. Which, if you remember, there's another name for Boxplot. Do you remember what the name was? Oh, it didn't want to stick to it. I figured it out how to do it. If I group this with that dot and say group it, they'll be together. There you go. So Boxplot is also called box and whisker because what I'm going to do is I'm going to take this box, make a whisker, and then I have to do the other side, so I have to make my whisker out here, and I just put a little mark there. The only mark I don't have in here is the median. The median, I circled it earlier. Do you remember what that median was?
75.
Okay, 75, so I had to leave it up so you could see it. 75, well, I didn't mark it. I went to 75, 70 to 80, so 1, 2, 3, no, 75 was here. Here it is. There it is, 75. And by looking at your heart rate data, that would be a box and whisker plot. Now, using our calculator, go ahead and tell me what the 5-number summary was. Because your calculator, I would probably not do it by hand if I don't have to. too much work, too much thinking. You gotta have a ruler and make sure you space out nice and pretty. And you know me, I'm not an artist, so I might look at my calculator. So go to your calculator. Yeah, give me those 5 numbers. Give me the min. 58. Give me Q1.
68 and then 75.
And then what's 75?
75 is a median.
Median. Let me see if I can move this this piece here, yeah. Yeah, you're fast. You're just too fast for me. Q3,
86,
and then after that was max.
97.
How does it match mine, what I just did? Oh, I did the 68. I changed my mind about doing the 68. I said, it's in there. It's in that 68, but the computer rounded it to 68 perfectly. Did I catch the 86?
Yeah.
I caught the 86. I caught the 75. So, hey, that kind of worked, that little system that I've done. It worked by hand. But I'd so much, if I was doing this for a test, I've got my 5 numbers. I'm not going to work that hard. I'm going to do this. I'm going to go 1 number, my 2nd number, my 3rd number, my 4th number, my 5th number. It's not even it's not going to look the same, by hand. But the person is going to have to realize that I have a life, and I'm not going to spend forever if I'm going to draw it on a test. And then I'm going to label. I'm going to label 58, 60, 58 to 68. It's bigger than, it's supposed to be a big size of 10. Then all the way to 75. You do know that's the smaller distance than this. 75, 86, and then 97. So that's what I would do for my box plot on a test. It's not to scale. It's just the numbers are in the right place. So you don't have to sweat it. I know and you know that if we're doing it by hand, we're not going to work and spend 15, 20 minutes on it. It'd be nice if we always had time to do a scaling and be able to do that so you can get a perspective. All right, yes.
For the test, can we do it in the calculator, or you want us to do it by hand?
Oh, on a test?
For your test.
Most tests are like the AP, so it's calculator.
Calculator?
Yeah, this is a quiz, so every once in a while you'll see a hint where you're doing it by hand because it's a small set of data. Warm-ups and homework. It's more important in the AP test that you can use your calculator. But the math teacher in me still wants you to know the math, right? So there's a balance. There has to be a balance. I wouldn't be doing justice with you if I just taught you the calculator, but never truly explained to you this magic of 25% of the data that this represents 25% of the data, or 1/4. And then this is another 1/4 of the data. It would not be, and this is all 50% of the data. I need you to convey that thought, even though I'm not mean. I'm not going to say, oh, everything has to be done with the rulers, and no. You know what I'm saying? So, now, what I don't know for sure is if any of you, did we do the outlier test on your data? Does anybody remember if we did? No? Okay, then let's do the outlier test. We did it? I know I did an outlier formula with you. There was
Yeah.
none?
No, we did
But
it.
I don't know if it was from the post.
All right, well, let's do this. Let's just take our word that this could be, one of those could be an outlier. Well, hold on, you got a calculator. Go ahead and do the calculator step and do the modified box plot. That'll tell us if it's an outlier.
Oh, yeah.
And if you don't know what I'm talking about, you need to raise your hand. I only will yell at you once, but I will still show you. But I'll say, what happened? We just did this.
No, we don't have any.
No outliers. Okay. So let's Roger Barris did. Oh, that's the data right down there.
That's the one that we did.
We did Roger Maris. Was that an outlier?
Oh, no, we did
We did NFL. Why don't we do this data here? Let me copy this data. And I'm going to put it on a blank page here. Yeah. Oh, I'm so proud of myself. I'm getting kind of good at some stuff here. You see, old dogs can learn new tricks, except for my dog at home. She's not wanting to learn nothing new. Goldie is not wanting to learn. I think she's got to be close to 6, 7, 8, 9, 10, 11 or 12 years old. She's just happy. So here's Babe Ruth data. So we must have looked at the Stemplot, remember? Yeah, we looked at the Stemplot and realized that Babe Ruth had a very consistent home run average per season. Maris snuck up and Maris broke his record right here at the 61 right here. He broke the record because Babe Ruth never had 61 home runs in a season. So some people were honoring him as the king of home run hitters. Well, it's not really fair because Babe Ruth had the record on many, many seasons all the time. He broke his own record. But anyway, if we're going to do a box plot on this data, I'm just going to do Roger Maris, okay? Just keep it simple. I'm going to do Roger Maris. Put Roger Maris in your calculator. I know he's not going to like it because it's a small fit, but yeah, you're going to put Roger, you're going to tuck him in there.
Do we put both of them?
No, just put Roger Maris. He would be happy if he was in there with Babe Ruth, you know, but the tight fit, so. Can you imagine what it'd be like to be in a calculator? And see all these bits and bytes going by you, 100 miles an hour? Hey, what's that? I'm at least doing a square root. So I'm gonna need my 5-number summary. I'm gonna need my Q1, no, I don't have a Q1. Silly me. It's called a minimum, right? Minimum. Then after that, Q1. Then my median, 8.
And then Q1 is 13.
13
And then it's 21.
is my median.
And then 29.
Q3 is 29, and the max
Yes.
was 61.
Yes.
So I'm gonna do this old style here. I'm just gonna go line, start out at 8, max was 61, and I'm gonna put Q1 is at 13, and my median is at 21. Obviously, nothing is to scale, and so here goes. Here's my magic box plot that makes the teacher happy. As long as you label this stuff, there you go. There's my whisker. There's my whisker. And I noticed, wow, that whisker is a little farther because it is a long distance. I wonder, remember our eyes? I wonder if that's an outlier. So
Can you check in the calculator?
we can check it, but I'm still showing you by hand here. The formula by hand was, do you suspect the 8's an outlier? It's close to 13. Do you think it could be an outlier?
No. I feel like 61.
Okay, so we're going to use this one. Here's your formula. It would be the Q3 plus 1.5 IQR. If you recall, IQR was Q3 minus Q1. So that would be 29 minus 13. Yes.
The formula is 1.5 times IQR.
Added to Q3.
That's so.
That will tell you the last value that would not be an outlier. Now, if I suspect this way, I would have to do Q1 minus 1.5 IQR. Going this way. But you just said we think it's this one. So IQR was 29 minus 13. How much is that? Not all at once.
8.
18 or 16?
16.
16. So Q3 was 29 plus 1.5 times 16, which means 1.5 of 16. So half of 16 is 8. So 16 plus 8 is 24. So 29 plus 24. The largest value that I'd be allowed to have, and not an outlier, is
53.
53.
Wait, is it 53?
I don't know, she did it. 40, 49, 53. That means if I had a 53, it could be out to here. And then that means everything else is an outlier after 53.
So 53 is not included.
53 is not included. It's the last value that is not an outlier. 53.01 would be an outlier if it was decimal data. So it's obvious this is an outlier. Now, those of you that did your box plot and you have the data in, do the modified box plot and tell me what it did at 61.
It's like outside. Okay. It's coming from here. See. That's the outline.
It's an outlier?
Yeah.
So what it did was you had this nice pretty box here, and all of a sudden it made an end of the whisker, and then it made a star out here, right?
Yeah.
If you can see that. It went out there. And this end point here may not be 53. It's the closest number to 53 in my data, which is what? Closest, no, well, I have a 50, I have no 50s. 33 might be the smallest. And if you hit trace, it went to 33 because it's the only data that was not an outlier. It's the farthest data it could go. I could have gone to 53, but 33 was the data point that I had. So that's where the whisker goes. The last data that was in the set that was not an outlier. So does that help a little bit? All right. So I'm going to move on now. That was a reteach of quartiles, box plots, outliers. Okay. Did we do the? I think we got to do that once in a while. The work we did the other day. All right. Your next set of notes. We did all this. That's what I wanted. Standard deviation. You had some homework problems that had it. If you were to turn in your homework today, like I was going to have you do, I wasn't counting anything that had standard deviation anyway, okay? Because it wouldn't be really fair. I mean, yeah, your calculator gives it to you. It was the one labeled what? S of X. That's standard deviation. But none of you know what it means, really. So I'm going to show you mathematically what standard deviation, how we calculate it. But I'll be honest with you, it is so much work. We let the calculator do it most of the time. Okay? So, matter of fact, right now, you are going to use your calculator. And we've got 5 different classes that took an exam. Small classes, only 5 people in each class. So, quickly, make a list 1, 2, 3, 4. Where's the 5th one at? I don't see 5 classes. I see 4 classes. I'm sorry. Let's read it right. It helps to read the directions. 4 classes, each containing 5 students, took exams. Well, I did say there was 5 in each class. So there's 4 classes. So I just need the mean, the median, and the range of each of these classes. I'll let you tell me when somebody has the 3 numbers for class 1.
And 80,
80, 80, and 0. We'll come back to that and see what is going on here, okay? So, oh yeah. So, okay, never mind. We will not come back and talk to it because Zuli decided to tell us the secret. They were all 80, so of course the average is 80, and of course the middle is 80, and the range, there is no range because there's only one value. There's no max and min, right? All right,
What is it just?
class 2, somebody who's... Did somebody actually key in all the 80s and do one variable stats? No? Okay. Amelie, did you type it all in, all the 80s?
Me? Yes. Everything.
She followed directions. She followed directions. Okay. Now, can I have class 2? Somebody?
Oh, I got it.
I have it. I'm honey. Whatever.
By the way, guys, I'm posting this one on YouTube.
Oh no.
Oh yeah. Well, you don't see it because I zoomed in. You don't see the recording. I'll show you right here. It's recording.
Hi.
Hi.
The
Yeah.
mean is 80.
80.
And then the median is like 80.
80.
And that's it.
What's the range?
Oh.
You could do the range by hand because it's only the max minus the min. The max 20. So the mean was the same again. Notice it. It was 80 before. It's 80 for that class. Class 3.
80, 100,
80. The median is 100?
Yeah. Wait, what?
How is the median 100?
I don't know, just. How do you know?
The median, I'm sure I didn't tell you. The median is a big M. It actually says median. It says median.
It says med, no?
Yeah, med. 80. And for those that didn't need the calculator, half of 5 is, take 5, it's odd. Round it to 6. Half of 6 is 3. 1, 2, 3. It has to be that middle term. What was the range? 40?
40.
And the last class, it's curious. You have all those hundreds. The mean is? They're 80s again?
80.
80, 100, and 100. 80, 100, and 100.
Oh my god.
So, it should be apparent that through the classes they have the same mean. That are quite different. The classes are different, but they have the same mean. Okay? The range is quite different for each. Yeah, look at that. 0, 20, 40, 100. And you need to think about the range as a variation. How do the numbers vary among each other? Obviously, if they're all 80s, they didn't vary at all. If they were all hundreds, they wouldn't vary at all. But this one still had all hundreds, but it's still a 0. They still didn't vary as a group that much. But the range was still 100. Okay? Range is a measure of spread, how far apart the data is. It's not the best measurement. Not really. Range doesn't really tell us a lot except for max and min. The ones that are usually used in is variance. So there's another word for you. That actually is another measure of spread called variance. And the symbol is s to the second power. What was s? Oh, so if you take the standard deviation and square it, you get variance. So why are we talking about variance? We haven't really explained standard deviation. However, that's what variance is. It's a measure of spread. So we're going to figure out how to find the standard deviation by hand. Steps are quite simple here. You could probably follow it. You first have to find variance. That's why we need variance before I talk about standard deviation. We got to find the mean. Okay, that's easy enough. We found the mean for every one of these. Then what we have to do, for each score, we subtract it from the mean. So I'm just going to randomly pick, well, I'm not going to do too random. I'm going to pick the list of data that looks more different. Like, I'm going to pick class 3. So can you list me the data for class 3 again, just so I have it written right here?
The mean
No, I want all the data.
is 100,
I can't start coughing. 100,
90,
oh, 100,
90,
90, 80,
70,
60. And what was the mean? This is just my sum. This is my x's. I'll call those x's. Now my next column will be x minus x bar, which is the mean. And the mean you already did. What was the mean?
and the mean was 80.
So I need 100 minus 80. I need 90 minus 80. I need 80 minus 80. 70 minus 80 and 60 minus 80. And those answers are, please don't use calculators, 20. What's the next one? 10. Next, 0. Next one? Negative 10. Negative 20. Got that? The next step, I'll read it with you. It says, square the result for each of those values. So next column is the x minus x bar all squared. So I'm going to have to square every one of those numbers. And I hope some of you can do that without the calculator. What is 20 squared? 40. What's 10 squared?
No, I'm wrong. Wait.
Yeah, you are wrong.
Yeah, I know.
It's 400. You were close. What's 10 squared? 100. Notice I didn't even catch it. I just trusted him. What's 0 squared? What's 10 squared? Negative 10 squared. It's still 100. This is why we're squaring them. Because some were negatives and some were positives. By squaring them, you get a number. Yeah, you get a number that doesn't affect left or right. After the 100 is how much? What's a negative 20 squared? A 400 again. So we did that. What's the next step? It says, add all of the x minus x bar squared. So all I'm going to do right here is I am going to add all of these up. I hear calculators, that's okay.
1,000. Yeah, 1,000.
Exactly?
Yeah.
1,000. So, what does that give me? Well, that gives me, if you look carefully, to find the standard deviation on a set of n pieces of data, we first find the variance. Then we take the square root of the variance. So this value here, I'm going to label it. It is, anybody figure it out? It is the variance. Variance is s squared. The sum of those differences squared is your variance. You have to find the variance first, and the variance was 1,000. To find the standard deviation, it says to take the square root of the variance. So I'm going to go square root of s squared. In this case, square root of 1,000, and I might need a calculator for that. It's approximately,
A million.
no, square root, not square. Square root.
31.62.
That's why I said a calculator. 31.62.
Wait, I had a question.
Yes.
So, why did you say letter E?
I don't know. Did I?
divide that sum by.
Like it says to find the degrees of freedom.
Oh, yes, I did mess up. Forgot to divide. Thank you, Mallory. Find your quiz and add 5 points to at the top, okay? I forgot to divide by the degrees of freedom. Yeah, I didn't even read letter E. Shame on me. So that was not variance yet. It would be variance once I divided by n minus 1. N stands for how many terms do I have? I'm going to erase my other work here because it's obviously that I got ahead of myself. Whoop. I'm going to have to do it this way, I think. Oh wait, no, that won't help a whole lot. Well, okay, it's not going to let me erase it now. Whoop. Well, let me just do this. Oh. I'll just do it all over again. Good enough. All right, so what is n minus 1? Yes, n is 5. So what's 5 minus 1? That's 4. So what's 1,000 divided by 4? 250. N is how many terms you have. How many students in our class. Thanks for catching that. So we had to divide by n minus 1. Always n minus 1. It's a degrees of freedom. That's a term. And there's whole lectures on why is it n minus 1? Because sometimes some things you just divide by n, that's the average. But because there's one variable, you take the number of terms, number of items you had, and divide by the 1. That is what we always use. All the time. You're going to see it again later and later. So, oh, n minus 1, n minus 1. So this is called my variance. So I will label it correctly now. S squared, that's my variance. Square root now of 250 will be my standard deviation. Somebody? 15 what? 15.8. Good enough. I really did think that bigger number was kind of high, but I remember doing this, but because I did read the whole thing. He gave you all the chart to also do it. So here's all your columns that you could use. Here's your values. Subtract your average to each. Square every number. Then he does, this is all one class. This is all one class. You see that? This is all one class. Divide by 4, because that's the degrees of freedom. That's my variance.
Wait, sorry, I have a question.
Yes.
Let me see. So class 1, you add all the numbers and then you get the sum and then you divide it by 4, right?
Yeah, we can do that in our head. This one's easy. Watch. What's the average of this class?
80.
So what's x minus x bar? 80 minus 80. 0, 0, 0, 0, 0. Square each of those. 0, 0, 0, 0, 0. Add them all up.
0.
Divide by 4.
0.
Take the square root. That's why I didn't grab that class. It's boring. But the point is, if they're all the same, they didn't vary, did they? So your standard deviation is 0. If I go and do class 2, well, that's a little more exciting. Wonder where that came from. That was my answer to the other problem, wasn't it? Okay, just stay there. What was the average for this one? Again, weren't they all 80? So what's 90 minus 80? What's 85 minus 80? What's 80 minus 80? 75 minus 80. 70 minus 80. And now we have to square them all. 100, right? 25, 0, 25, 100. Add them all up. 100 plus 25 plus the 20, that's 150. Is it 250? 250. Then I have to divide that by, I didn't get the 50, the 0. Hold on. I didn't divide by 4 yet. What's 250 divided by 4? 60.5? 62.5. That's the variance. You write that again. Variance. Because we divided it by the degrees of freedom. Now take the square root. That's your standard deviation. Now take the square root. It's got to be less than 8. 7.91. It's higher than 0 because it has a lot of, the numbers do differ more among each other. There's a variance. It's actually, if you think about it, if the average is 80, this number is basically giving you how far are the values from the average. So the average was 80, but most of these numbers were not at the average. You got a 70, 75, you got an 85, 90. There's more variance from the mean. Whereas when the mean was 80, and they're all 80, they never differed from the mean. We already did class 3. We did this one already. What was our answer? Wasn't it 15.8? I'm going to write it here just in case you're going back and you're going to use that maybe. There's one more class. Okay, average was 80. Now, would you say that most of these were close to the average? Wasn't the average still 80, or are they far from the average? What is the average? 100 is not far? But the thing is, what's the average distance away? Let's see how this works out. Intriguing questions. 100 minus 80. 20, 20, 20, 20. 0 minus 80. Negative 80. Ooh, that's going to be the stickler here. Square them all. 400, 400, 400, 400. What's 80 squared? 6,400? It's huge. Were you expecting it to be that big? Now we have to add those up. You can use your calculator. It says it's 72,000 or 7,200. Now this was 80 times 80 was how much? Is it 6,000 or 64? I'm sorry, I had it wrong. 8 times 6,400, not 6,000. So help me out. What was the sum? That was 64. 8? What is 8,000? Oh, the total's 8,000? But this number is supposed to be 64, right? 6,400. So I turned it into a 0. But the whole thing you said adds up to 8,000, you said? 80,000 or 8,000? 8,000. Then we divide that by how many? 4? That's 20,000? 2,000? And what do you do with that 2,000? Because that's called the variance. Square root it, that's the standard deviation. 24 point what? 72? So there's your standard deviation. Compare it to the other ones. 24 versus 15 versus 7 versus 0. Why is it so huge?
Because they're far away from me.
Yes, thank you. All those numbers was 20 away from 80, and this 0 was 80 away from 80. So it's a measure of away from the mean. Where are you in respect to the mean of the class when you get your test scores and I tell you the standard deviation? It says to you that this is roughly where we are at as a class. I mean, it doesn't tell me exactly you individually, but as a collective unit, what the average is, it's a measure of spread among that distance. It's not a good test when the standard deviation is high. That means the class average was somewhere and everybody else was way somewhere else. We weren't hitting the average. Now, it's okay if the average was 70 and the whole class got hundreds. We don't mind that standard deviation, do we? But what if we all got 40s? Not so hot.
So if it's like above the average, would it be a negative number?
Well, it can never be negative because you're always squaring those differences.
So how would the standard deviation look like if it was above average?
Well, it would be no different. It would still be a positive number. You don't have any idea unless you looked at the distribution and looked at the shape. If you saw the shape was skewed to the right and the standard deviation was 12 points, then you can probably rest assured a lot of people had an average higher than the mean or had the higher than the median. So at least, your mean got pushed up higher. Yes.
Sir, wasn't the standard deviation 44.72
Which one for here?
for the last one?
Oh, I don't know. I was just taking their word. They said they did the square root.
It was 44.
Oh, and what do I have written here? Oh, I didn't lock it in. Darn. It moved it around. It wasn't 24, it was 44? Oh, okay. I think that even makes the argument more there, right? It was already higher, now it's a lot higher. Thank you. Oh. Thank you for catching that. I heard 24. But that even makes it even more of an argument of how high it is. Whoop. Say it again. Questions? How to do it by hand? Tell me how to do it with a calculator.
I think I know. You put the numbers in the whatever L1,
Yes.
and then you go to calc, and then you put like
Yes.
the first option, so you click enter, and then you see like S, X.
Yes.
and
That's
the
right.
standard deviation.
That's the easiest with a calculator. All right. All right. Say goodbye to the virtual world.
Bye.